All right, these notes are on your least common multiples or your least common multiple and your greatest common factor, your LCM and your GCF. So first, let's take some definitions, write some definitions here. So what I have done is modeled what LCM stands for, least common multiple, and modeled what GCF stands for, greatest common factor. And the good thing is we've kind of worked with these a little bit in class. So what we have to understand with these, the greatest common factor and the least common multiple, is you have to understand what is a multiple and what is a factor. Both deals with multiplication, but you have to understand the meaning of the both to be able to apply the skill. So a multiple is a product of any quantity of an integer. So if your integer is 2, okay, what are your multiples? 2 times 1, it's 2. So it's the product of any quantity of an integer. So if your integer is 2, how many is 1 of them? How many is 2 of them? How many is 3 of them? How many is 4 of them? So 1 2 is 2, 2 2s is 4, 3 2s is 6, 4 2s is 8. So you kind of list them. If you're ever asked what a multiple of a number is, you just count by that number. So your multiples are 2, 2, 4, 6, 8, 10. Your multiples of 3, 3, 6, 9, 12, 15. So you just count by those numbers. It gets more difficult when your integers that you're asked to find multiples of become larger, like 32 or 56 or 478. So that's when it becomes a little more challenging. But you have to have the basic understanding of what a multiple is. A factor. A factor is the numbers that are multiplied to get a product. So if you're asked if your product is 18, that's your answer. What did you multiply to get that answer? Those are your factors. So you multiply 9 times 2 to get 18. You can multiply 1 times 18 to get 18. And you can multiply 6 times 3 to get 18. Once you have all those factors, you just list them in order. 1, 2, 3, 6, 9, and 18. You find the LCM and your GCF when you're comparing two numbers or integers. There's a lot of ways to apply this. You're thinking, why do I have to understand my least common multiple or my greatest common factor? Honestly, there is a lot in life that you use it for when you're planning dinners. For example, here's a big one in life. You buy hot dogs in packs of 10 buns, but your package of hot dogs come in 8 count. So it's like, ooh, so you don't want any leftover. You have a 10 and you have an 8. You don't want any leftover buns. So why do you have 10 buns, 8 hot dogs? Why can't they just sell them 8 and 8? So you have to figure out, well, how many hot dogs and packs of hot dogs and packs of hot dog buns do I have to buy so I don't have any left over? And so you find your least common multiple between the two. And greatest common factor comes in handy when we are simplifying big time. So in math, understanding greatest common factor is going to help you when you're simplifying fractions and math problems to come to your simplest form, or just basically simplifying your work. You'll need your greatest common factor. So here is an example. So we have, ooh, let me move that down. Ooh, okay. So if your integers are 12 and 18, to find your least common multiple of 12 and 18, you would list your multiples of 12, 24, 36, 48, and 60. Then you list your multiples of 18, 36, 54, and 72. And then you would just identify, I did it by circling, the smallest multiple the two have in common. You do this when you're finding a common denominator when adding and subtracting fractions with unlike denominators. You find the least common multiple, and that's what their denominators will be. And then you work out the math to change the numerator. Then you can do the same thing. You can find the greatest common factor of 12 and 18. So here, as you can see off to the side a little bit, let me move that down. You see I've kind of worked out what are my factors of 12, 1 and 12, 2 and 6, 3 and 4, and then I listed them 1, 2, 3, 4, 6, and 12 in order from least to greatest. And then I did the same thing for 18, 1 times 18, 2 times 9, and 3 times 6. And then I listed them in order and found that the factor, the biggest factor, the greatest factor these two have in common is 6. And therefore, if your fraction was 12/18, if you divided them both, the numerator and the denominator, by 6, you would put your fraction in simplest form. Let me write that down here for you. So if you have 12/18 and you found that the greatest common factor was 6, you could divide them both by 6 and you would get your simplest form. So that's how it can be applied in math. Another kind of cool way is looking at the distributive property. Now, I don't know. I mean, sometimes our brains think like this, sometimes they don't. But it can be used to solve problems in our brain or in our mind, mental math. So if I'm doing a simple problem of 8 plus 12, I mean, I'm using a simple problem to model it, we all know that 8 plus 12 is 10 or 20. We all know it's 20. But here's how we could use this whole factor thing. We know that 8 and 12 are both 8 and 12 are both multiples of 4. So we pull the 4s out. Okay, and we say 4 times 2 and 4 times 3. And then once we do that, we pull it out, okay, and add the two differences. So we know that they're both going to be multiplied by 4, so we use that whole distributive thing. And we do pull it out, we add the two factors that are different together, and we get 4 times 5, which is 20. It works when you're dealing with really large numbers. Here, it kind of seems silly to use it, but we like to show new things in simple ways before we apply it in more bigger ways, okay? But it is a way that if you understand what the least common multiple or a common multiple of the two, actually in this case it would be the greatest common factor of 8 and 12. The greatest common factor of 8 and 12 is 4. And you pull those out and then add the factors that are different, multiply 4 by those two factors added together, and you'll get your answer. There is another way to find greatest common factor that we're going to practice in class. Actually, there's two different ways, but one way is called using prime factors. It's something we call prime factorization. Sometimes when you're finding your greatest common factor and your numbers are really big, like 96 and 45, it can get a little lengthy trying to figure out all the multiplication. So what we can do is we can do something called prime factorization, creating a factor tree. So the easiest way to look at it, so if we have our factors of 30 and 50, we want to pull out our prime numbers for our prime factors. So you want to first find the multiple, the smallest multiple, or the smallest factors. Trying to explain this. We know 1 isn't gonna be the greatest common factor. It's never 1, and it's never the number itself. So forget 1 times 50 and 1 times 30. So let's look at the next smallest factors of 30 and 50. We see that they're both even numbers. So we know they're both divisible by 2. So if they're both divisible by 2, that means 2 is a factor. So 2 times what is 30? And 2 times what is 50. So we're gonna pull out that 2. 2 is a prime number. So we pull out the 2 and we get 2 times 15 and 2 times 25. And you go ahead and circle your prime numbers. And now you're left with 15 and 25. Those are not prime numbers. So we have to break them apart by their factors until we get to a prime number. A prime number are numbers that can only be multiplied by 1 and itself. So 2 is a prime number because you can only multiply 1 times 2 to get 2. So if we look at 15, what can we multiply 15 by? What are the factors of 15? Well, 1 and 15, but we know it's never 1 and never the number itself. So the next one, it's not an even number, so it can't, so 2 is not a factor of 15 or 25. It does end in a 5, so 5 is a prime number. The only way to get 5 is to multiply 1 times 5. And I know that 5 times 3 gives me 15. 5 is also ends in a 5, so it is a multiple of 5. So I know if I multiply 5 times 5, I get 25. So and 5 is a prime number. 3 and 5 is a prime number. So I pull those out, 5 times 5 and 3 times 5, and I circle them because they are prime numbers. And then we have, we've kind of finally gotten to the final prime numbers. We can't break apart 5 anymore, and we can't break apart 3. Then we look for our pairs. I know this is crazy. So one pair between 30 and 50 is 2. Another pair between 30 and 50 is 5. This one does not have a pair, and this one does not have a pair. Once you find your pairs, I have a pair of 2. You pull it out. And I have a pair of 5. You pull it out. And you multiply them. So, the greatest common factor between 30 and 50 is 10. Seems like a lot of work, but once you figure out the process. And there we have it. So the common factors are 1, 2, and 1, 5. Sometimes there can be more than 1, 2, more than 1, 3, more than 1, 5, okay? Another way to look at it are like, what are my prime numbers? Do you know what your prime numbers are? Prime numbers, you have 1, which is never gonna be 1. 2 is a prime number. 1, 2, 3. Is 4 a prime number? No, because you can multiply 1 times 4 to get 4 and 2 times 2. Remember, for it to be a prime number, you can only get that number by multiplying 1 and itself, which makes it prime. So 4 is not, but 5 is, because the only way we can get a product of 5 is by multiplying 1 times 5. Nothing else can be multiplied to get 5. 6 is not a prime number, because not only can you multiply 1 times 6 to get 6, you can also multiply 2 times 3, which does not make it a prime number. And then we have 7. So 7 is a prime number. The only way you can get a product of 7 is by multiplying 1 times 7. So 7 is a prime number. 8 is not a prime number because you can multiply 2 times 4 as well as 1 times 8. 9 is not a prime number because you can multiply 1 times 9 and 3 times 3. So here's some really quick prime numbers that you can use to build a factor tree using prime factorization to get to your greatest common factor. Again, this is a method. So here is another example I used with 30 and 45. So I broke apart 30. First I used 2 because it was an even number and it's my first small prime number. So start with the smallest one. So it's divisible by 2. So I know 2 times 15. And then 15 is not a prime number. I had to break it apart to 3 and 5 because 3 and 5 are my prime numbers and I cannot break them apart anymore. I did the same thing to 45. 45 is not divisible by 2, but it is divisible by 3. And 3 times 15 is what gets me that 45. I have my prime number, then I circled, and then I had to break apart my 15 to 3 and 5 because these are 2 prime numbers and circled them. Then I looked for my common prime numbers. 2 does not have a pair with 45, so 2 would not be one I would select. 3 has a pair here, so it has 1 3 in common and 1 5 in common. So because there is 1 3 that has a pair and 1 5 has a pair, I multiply 3 times 5 and get 15. So the greatest common factor between 30 and 45 is 15. And then I tried something a little crazy with even larger number, just to show you guys how it would look with an even bigger number. So I have 96 and 144. It was quite a big factor tree. So 96 is an even number, so I know it's divisible by 2. That means 2 is a factor. 2 times 48 gives me that 96. And again, 48 is even, so I pulled out another 2, another prime 2. 2 times 24. 24 is even again, so I pulled out yet another 2. And 2 times 12 got me that 24. 12 again, even, pulled it out again. 2 times 6. 6 again, even, pulled out another 2. And 2 times 3. Finally got to my last prime numbers. 144 went through the same process again. 144 is even, pulled out a 2. 2 times 72 is 144. Oh, even number again. I don't know why I circled that. I should not have circled that. 72, I get circle happy. 72 divided by 2 is 36. 2 times 36. So we pulled out another 2. 36, another even number, 2. 2 times 18 is what gets me that 36. Oh my goodness, another even number. 2 times 9. Now we have 9. 9 is not an even number, but I do know the 2 prime numbers that are factors of 9 are 3 and 3. And then you find your pairs. So you start up, 1 pair of 2, and I listed the first one. The second pair of 2, listed the second pair. Third pair of 2, listed the third pair. Fourth pair of 2, listed the fourth pair, and I have a pair of 3s. 2 here and the 3 here do not have a pair. Then you multiply 2 times 2 times 2 times 2 times 2. I got all my work and got to 48. So the greatest common factor of 96 and 144 is 48. So this is where using prime factorization, building a factor tree, can help you get to the greatest common factor of some pretty big numbers. So we'll work on it. There's one more method we're gonna do in class that's kind of crazy, but it's a strategy that we'll talk about.